On this episode of Behind the Scenes with Maana Q, we're going to pick up from our previous work on parametric polymorphism to talk about higher order functions. Those are functions that take as input or produce as output other functions. Recall that parametric polymorphism gives us the ability to write generic functions that operate on arbitrary types, such as reversing a list of type T. But what if we wanted to apply a function to each element of that list to do something special, such as doubling every number, or filtering out elements that don't meet some criteria? In these cases, we'd like to pass a specific function that operates on a specific type to the generic function. Consider the following example. I have a collection of people, Mary, who's 24, Bob, who's 42, a generic filter function, which works on a collection of arbitrary type T, and a predicate function, which is just a function that returns true or false. Now, the type of this predicate is something we're introducing here in this episode called a function ref. Function ref is simply everything that's needed in order to call into a service, invoke a function, with the right type definitions. So in this case, it's got the function name, as well as the input type, and the input name, as well as the output type, which are used for coercion. And what we'd like to do is specify that predicate function, in this case, the is under 40, which will simply take a person, look at their age, and return true if they're under 40, false otherwise. And the filter function then is going to reject those that are false and keep those that are true. The basic idea is that we will extend Q to have an assistant that does this for you. This is a behind the scenes, so we're simply showing what we're doing as we design these features. In this case, you would pick the generic filter function, you would pick the type person, and you would pick the predicate that it requires. And it will synthesize for you this filter people under 40 function that you could now use in your function graphs. Let's take a look at what we're going to need to do in order to extend the coercion routines that we added in the previous episodes to support these higher order functions. We want to extend the code that we developed for parametric polymorphism to include higher order functions. We can begin by adding enumerations for those function refs we just talked about. Now, these are going to be for the outputs because GraphQL requires you to have input types. So for each, we have a required and an optional variant, and then we're going to have the input type variants. Now, we don't need those on the others because they're just JSON, and JSON doesn't have their scalars, so they don't have input variants. And the way CKG does its naming is it does whatever the name of the kind is plus as input. So we'll just do that here. And we'll change these to be inputs. Now, we don't need to do anything else to this boilerplate. This can stay exactly the same because these just get passed through to whatever the specialization functions happen to be. These don't require coercion. They'll make it through as the types that they're defined as. But what does need to change is the coercion plan. We have here the filter with the generic type, these are the X's, but we need to add that predicate. And again, this is something that the assistant will be specializing each case for. And in this case, we'll just use that new enum that we just defined. And this is a function ref as input, and it's required. Now, we actually need the input data that includes that definition. This is just for the coercion. So what we want to do is we want to inject that input into the inputs that we're sending to the specialization function. The assistant would just fill in the details for the specialization function. In this case, it's the service reference to the workspace that has the function is under 40. That has an argument person of type person as input, which is required, and returns a required Boolean. So this has just been injected into the input variables along with the actual X's of the collection. And all of this will just be passed through by the boilerplate without coercion. The next thing we need to write is the generic filter function. So let's just go ahead and put that at the top. The generic filter function is just going to be a lambda, which we can mock up here in VS Code. And for every element of the list, we need to call that predicate function. And if it returns true, we keep the element. And if it returns false, then we throw it away. We can do this in 2 stages to try to get some parallelism here. Instead of waiting for every call to return, we can dispatch a bunch of them, collect all of the true falses, and then use those to filter through the list. The first thing that we do is destructure the input. We get access to the collection of x's, the predicate, function ref, as well as the CKG client. And then we want to map over every element of that collection and perform this GraphQL query, which we assemble here involving the function name, the input name, and the input type. We're also going to pass in the variables using the input name, and we need to parse the x because we received it as a JSON string. So this is where, even though you're writing a filter function, you need to do a little bit of coercion if it's a generic. And it's simple because it's just a JSON parse. When this returns, which we've done here as a collection of promises, we will then use the results, which are collections of true or false, to then remove the element from the array. I've copied the code from the test environment and pasted it into the Lambda assistant for both the filter operation as well as the wrapper function that our future assistant will produce. So the last thing that we need to do is test it in the real environment. So I've made a small test harness here called test filter people under 40. And if we look at the function graph, it simply pulls all the people, which in this case is Bob and Mary, and puts them through the filter operation. So when we run this, we ought to see just Mary as the only item on the resulting list. And we sure do. That's all there is to it. In order to support higher order functions as part of polymorphism, all we had to do was add a few enums and introduce a new concept of a function ref that we could use whenever we wanted to pass around a function. While this was just a toy example, you'll see on the upcoming episode on conditional execution how we use higher order functions to control flow through a function graph. Stay tuned.